So today, the student will be able to use their knowledge of solving quadratic equations and also solving linear inequalities in order to find all possible solutions for quadratic inequalities. That's a lot of information, but basically, you know how to solve a quadratic equation. You know that you can do that using factoring, using quadratic formula, using completing the square. Today, in the notes, I'm going to use factoring. Okay, but technically you could use the quadratic formula and it would work. Or whichever one else is your favorite. But most people yesterday mentioned that they like factoring best. Excuse me. We're also going to use our knowledge of solving linear inequalities. We did linear inequalities, but it's been a while. So we're just going to take those two things that we know and put them together in order to find the solutions for quadratic inequalities. So you're not really doing anything like brand new mathematically today. You're just kind of putting two things that you know together and following some new steps. So that's why we're going to use 2-column notes. All right. Your instructions are to solve each quadratic inequality algebraically, which just means we're going to do it without a graph. So like I said, I'm going to use factoring today. All right, so the first thing we're going to do is we're going to set the quadratic equal to 0 because that's the first step in factoring, okay? So if you're going to factor it, you need to set it equal to 0 first. And then, but when we do that, the main idea is we are ignoring the inequality sign and we're changing it to an equal sign just for this first part, okay? So we're going to minus 2. So I have x squared plus x minus 2 equals 0. So for this first part, we are taking away the inequality symbol and we're pretending that everything equals 0, just like yesterday. Okay, so we're going to solve this. So solve the quadratic equal to 0. I'm going to use factoring, like I said. So I'm going to make a chart. A times C is -2. I need two numbers that multiply to -2 and add to B's +1. Those are 2 and -1 will work. So I have x plus 2, x minus 1, all equals 0. Divide by a. Well, a is 1, so that's not really going to change anything. X plus 2, x minus 1. Okay, now we're going to solve both of those. So we have x plus 2 equals 0. X minus 1 equals 0. So minus 2. X equals -2. Okay, so our factors are 2 and 1. -2 and 1, sorry. -2. Okay, but we haven't done anything with this inequality. So we're not finished. Okay, so step 2. Yeah, we'll use the same color. Make a number line. You cannot answer the inequality symbols today unless you have a number line. So we're going to make a number line. And when we make this number line, we're going to put the two numbers we know on it. So we know -2 is somewhere to the left of +1. Okay? Now, step 3, I'm going to do in a different color. That might be hard to see. Step 3, we're going to choose and test other numbers. Okay? We're not going to test -2 and 1 because we know that those make the inequality equal, right? So those are there. And because our inequality has a line underneath, we know we're going to include those in our answers. but we need to choose other numbers to figure out which direction this number line should shade. So if I choose a number between -2 and 1, 0 is an easy number to pick between there. It doesn't matter how close you are to either of the numbers, it just matters that it falls in that spot on the number line. A number bigger than 1, well, let's use 2. A number smaller than -2, let's use -3. Okay, so now you're going to test these in the original equation, okay? So when I test -3, I have -3 squared plus -3 less than or equal to 2. -3 squared is +9, plus -3 is really just -3. 9 minus 3 is 6. 6 is not less than or equal to 2, so I'm not going to shade the number line that direction. That's wrong. Okay, now let's test 0. So 0 squared plus 0 has to be less than or equal to 2. So 0 squared is 0 plus 0 is 0. 0 is less than or equal to 2, so I am going to shade the center of the number line. Okay, let's test +2. 2 squared plus 2 is less than or equal to 2. 2 squared is 4 plus 2, so we have 6. That is not less than or equal to 2. So I know that my answers are shaded this way on the number line. Okay, now this is where you need to think back to linear inequalities. When your shading comes together, it's an and statement. When your shading is separated, it's an or statement. So now we're going to write the final answer. And when we're thinking about and, or, okay? When they come together, it's and when it's and, that means you can put your variable in the center. So all of my x's are greater than or equal to -2, so -2 is less than or equal to x, and all the x's are less than or equal to +1. So when you use less than inequalities, you put the smallest number on the left, okay? And that's the answer. So we're going to pretend the inequality doesn't exist, and we're going to use equal to. Then we're going to make a number line. We're going to choose and test other numbers, and then we can write the final answer. All right, example 2. First, I'm going to solve pretending it's equal to and not an inequality. I'm going to use factoring again, and the first step in factoring is make it equal to 0. So I'm going to move the 6. So x squared plus 5x plus 6 is less than or equal to 0. Okay, so I need two numbers that will multiply to a times c. 1 times 6 is 6, and add to b is 5. So 2 and 3. Yeah. So x plus 2, x plus 3. Oh, this was supposed to be equal because we were pretending it is equals 0. Okay, now divide by a. A is 1, so nothing changes. X plus 2 times x plus 3. All right, so now we need to find our two answers. So x plus 2 equals 0. X plus 3 equals 0. Minus 2. X equals -2 is one solution. X equals -3 is the other. Okay, so after I solve, then I can't do anything. I've pretended everything was an equal sign at this point. So now I need to put the inequality back, and I need to make a number line. So make a number line. Sorry, my dog just came in. Okay, on our number line, we're going to put the two answers we already know. So we know that -3 and -2 make it equal. -3 is less than -2, so they need to go that direction on the number line. Okay, step 3, I'm going to use another color just so I don't get confused. We're going to choose, oh, I think you can see that color, okay. Choose and test other numbers. So if I pick a number bigger than -2, I'm going to go with 0 just because it's easy. You could have gone with -1, or you could have gone with 5, or you could have gone with 100. Anything that's to the left of -2, or to the right of -2, sorry. Okay, to the left of -3, I'm just going to go with -4. But in the middle, I'm kind of like stuck because they're right next to each other, so I have to pick a decimal value. So I'm going to go with -2.5. But -2.5 is really -5/2. And we're going to use fractions. Okay? All right, so now let's test those. So first, -4. So -4 squared plus 5 times -4. Is that less than or equal to -6? So -4 squared is positive 16. 5 times -4 is -20. Is that less than or equal to -6? Well, that's -4. -4 is not less than or equal to -6. It is greater than -6. So this doesn't seem to work. Okay, let's do 0 first, and then because I'm going to need a little bit more room for that fraction. So let's test 0. So 0 squared plus 5 times 0. Is that less than or equal to -6? 0. No, 0 is not less than or equal to -6. It's greater than -6. So we can assume that the middle is what's going to get shaded, but we need to test it just to make sure we didn't make any mistakes anywhere. So if I take -5/2, okay, so -5/2, we're going to put it, so parentheses, -5/2 squared plus 5 times 5/2. So less than or equal to -6. Oh, this should be a negative here. Okay, -5/2. -5 times -5 is positive 25 over positive 4 is 5/2 squared. Now, 5 times -5/2 is like 5/1. And when you multiply fractions, you just multiply across. So 5 times -5 is -25 over 2 times 1 is 2. Is that less than or equal to -6? Well, I need them to be common denominators before I can subtract. So I need to take 25 over 2, and I need to make it something over 4. So 2, in order to get from 2 to 4, we're going to multiply by 2. So multiply by 2, it's really 50 over 4. So 25 over 4 minus 50 over 4 is -25 over 4. We need to know if that is less than or equal to -6. So -25 over 4 is really -6.25. And -6.25 is more than is more negative than -6. So it is less than, because it is to the left of -6, because it's just bigger on that side. So yes, it is a bigger negative number, so it is less than -6. That means we're going to shade. Well, first of all, we need to know, do we need open circles or closed circles on -3 and 2? Because of the or equal to, we're going to use closed circles. And we just proved we're going to shade inside. So when we write our final answer, we have all the x's in the middle. If we use less than symbols, we need to put the smallest number and then the largest number. So all of my x's are between -3 and -2. -3 is smaller than all the x's, and all the x's in my answer are smaller than -2. Okay, last example. Step 1, pretend it's an equal. Okay, so we have, and I'm going to factor, so I need to move, so minus the 4. So 2x squared plus 2x minus the 4 is equal to, we're pretending it's equal to 0. Now, the first step in factoring is make sure it equals 0. The second step of factoring that we forget a lot because we don't always need it is find the GCD. Find the greatest common divisor. If I'm looking at my coefficients 2, 2, and 4, 2 is a factor of all of those. So I need to take the 2 out and then put what's left over inside. So I know they can all be divided by 2. So in order to figure out what's left, I need to divide it. So 2 divided by 2 is 1. 2 divided by 2 is 1. And negative 4 divided by 2 is negative 2. Okay? Now when we factor the next part, we are only looking at these inside pieces. Okay? So I need two numbers that multiply to a times c. My new a and my new c are 1 and negative 2. So multiply to negative 2 and add to the new b 1. So if I use positive 2 and negative 1, that will work. So I still have this 2, but now I'm going to build two binomials. So x plus 2 and x minus 1. Okay, now when I find the actual answers, I can forget about the 2 because I can't set it equal to 0 and solve. But I can say x plus 2 equals 0 and x minus 1 equals 0. So now solve those. X equals negative 2. And x equals 1. Okay? Okay, so now, step 2, we're going to make a number line. All right, we're going to put what we already know. So we know negative 2. We know positive 1. All right, step 3. Choose and test other numbers. All right, so I'm going to pick 0, 2, and negative 3. And we put those in the original. So 2 times negative 3 squared plus 2 times negative 3 is it greater than 4. Remember when you have this situation, you have to square and then multiply by 2. So negative 3 squared is 9. So 2 times 9. 2 times negative 3 is negative 6. Oh, not or equal to, just greater than. Okay, 2 times 9 is 18. 18 minus 6 is 12. And yes, 12 is greater than 4. So negative 3 works. Now let's try 0. So 2 times 0 squared plus 2 times 0. Is that greater than 4? Well, this is all 0. And 0 is not greater than 4. Okay. Now 2 times 2 squared plus 2 times 2. So 2 squared is 4. So 2 times 4 plus 2 times 2 is 4. So 8. 12, yes, is greater than 4. So our answers here are going to shade away from each other. So I'm going to open circles. Okay, sorry. Open circles, and we're going to shade away. Okay, now step 4, we're going to write the answer. If they shade away, it's an or statement. So we have that all of our x values are less than negative 2, or all of the x values or the answer is greater than 1. So when they come together, you build one statement. When they go away, you have to build an or statement, making it two different ones. And then you just describe the numbers you have on the number line, okay? And that's it.